Hello and welcome to another episode of Fresh Thinking by Snowden Optiro. This is the second of 3 podcasts on sampling, and I'm very happy again to be joined by Mike Murphy. Mike is an industry-renowned expert on sampling. In the first podcast, we talked about some of the fundamental issues. In this podcast, we're going to dive a little bit more deeper into errors in sampling. So I'm going to get Mike to talk us through all the various errors with sampling particulate material. So, Mark, we talk about correct and incorrect errors. What are the differences? Why do we use those terms?
Well, this is probably the most useful part of Pierre Guy's theory on sampling is his discussion of the errors, and that's what I found most useful when first getting into this this topic. So basically, correct errors they're not actually errors; they're just variability that you can't avoid. So the first most important one is this concept of heterogeneity, right? Which is, you got homogeneity means it's all the same, and heterogeneity means there is variation in what you're sampling. So the first correct error you make is what they call the fundamental sampling error, and this just stems from the fact that if you have a pile of broken rock or crushed rock, the fragments are going to have different mineralogy, different concentrations of the element you're interested in or mineral. And as you collect a sample from that, usually by taking small increments throughout the thing, each time you collect a sample from this lot, it's going to be about the right concentration of the thing you're interested in there, but it's not going to be perfect. And then you can take another one, it's going to be different, another one, it's going to be different. And the average of all those ideally will be the true grade of the lot, but in effect there's a difference between your sample and the true grade, which is the fundamental sampling error. So that's really So
that's a correct error.
That's a correct error.
And what's the other correct error that we encounter?
So yes, grouping and segregation is the fact that, again, got to imagine our pile of rock. And grouping is the idea that it's clumpy, and that idea is, we've already spoken about density in the last podcast. You'll find that some groups of minerals clump together and some groups of gang minerals waste will be in other places. So the fundamental sampling error assumes everything's more or less completely mixed, and this is something we'll talk about more, whereas in reality, samples coming to us have these either clumps or layers, and again the layering often comes from the density issues. And again, as we take samples from that, they'll be about the right grade, but they'll be different. The important part is that the fundamental sampling error can never remove that. The grouping and segregation error, you can in theory remove that by mixing and homogenisation, but in reality you never will. So the two tend to add together to the two correct errors you're going to get.
So with that grouping and segregation error, there's 3 things that, as you sort of alluded to. One is density, the other one is size, and the third one is shape. Of those 3, I think you've already mentioned, is which would you say is the greatest contribution to the variability or the error? Obviously it depends, but in general, which would it be? Would it be density? Would it be shape? Would it be size?
Well, I think the important thing is it does depend. So density, one of the big issues is this thing called sifting segregation. So if you can imagine a pile of coarse rocks and you drop some fines in, it'll sift through the coarser lumps. So if the coarser lumps have a different concentration of the analyte you're interested in versus the fines, that's important in that case. But again, if the particles are being shaken, denser particles will tend to fall to the bottom, and you can also get this bizarre effect that if there's a lot of vibration, coarse lumps will come to the top. This is the Brazil nut effect, and you often see this on conveyor belts, that the stuff on the top is always very coarse and all the fines have sifted through to the bottom. When you get down to actually fine ground powders, like the sort of stuff they use in the final analysis, or even in concentrates coming out of a concentrator for base metals, because all the particles are very much the same size and all relatively dense, they tend not to segregate. So one of the things that amazes me is that you can do very poor sampling techniques on something like a mineral concentrate, grab handfuls as each load goes into the truck, and then you'll find that they can be put in a truck, shaken, put in a ship, shaken, travel to the other side of the world. Someone else does the same thing at the other end and you get about the same grade,
Right.
because you've got this homogenisation and lack of segregation happening in the materials.
So is there a rule of thumb between apportioning the, let's call it the correct sampling errors between the fundamental sampling error and the grouping and segregation error? Is, obviously one thing we can do with the fundamental sampling error is calculate it using the theory of sampling, but we can't calculate the grouping and segregation error. So how can we apportion that, the total error, or how can we sort of calculate that, or assume, what can we assume for that grouping and segregation error?
That's a very good question.
What's
And
your experience tell you?
well, I work on double. So take the
Right.
fundamental sampling error and double if you're doing very good sampling practice.
Right,
Could be even more if you're not.
right.
So I've actually have some mathematical experiments. I'm waiting to retire so I can actually get them going and try and quantify those numbers, because I think that's a very important question.
Right. So if density is a significant factor like precious metals, would you say then that the grouping and segregation error might form a larger portion of the total correct error?
Again, it depends. So if you're just at the crushed ore stage where you've got, chunks of galena or pyrite and whatever, obviously density is going to be more important in that particular set. And the important thing to remember is that each stage of subsampling, as you grind stuff down, the importance changes. So at, say, the pulp stage, fundamental sampling error is probably the only real issue. But it's really at that first crush and grind phase that density and sifting segregation significantly add to the FSE.
But if we think about the total error, let's set aside the incorrect errors for now. If we think about the total correct error, isn't it true that most of that error is incurred at the early stages of the sampling process?
Oh, very much so. Yeah.
So in that case, then grouping and segregation error may assume more importance than, say, the fundamental sampling error.
Yes, agreed. Agreed. But again, I think where a geologist comes into this, rather than just someone who thinks about sampling theory, is that they have some understanding of the mineralogy, the grain sizes they're dealing with. And I think if they're thinking about those, they can do a lot to minimise that fundamental sampling error, for example, in coarse grain materials, in which case it may be less important than the fundamental sampling. Sorry, the grouping and segregation error is less important than the fundamental sampling error because of the heterogeneity of that material. So as you reduce heterogeneity, fundamental sampling error tends to come to the prime.
Right.
Yeah.
Right. Okay, so let's think about the other main type of error. Let's set aside analytical error for now. Let's think about our so-called incorrect errors. So what are these? How would you characterise these in general first?
There are many, and I wish I'd bought the list, but I'm one of these people who knows where the list is, doesn't necessarily remember all the steps, but let's test the memory. So I've already spoken about probably the extraction error, which is you have a certain volume you wish to be your sample. You think a core tube or an RC hole is basically a tube. And do you get all that out?
Yeah.
Okay, and we talk about that.
So that's like outside return being an issue there.
Yeah. Then there's basically the delimitation error, which is you aim, the thing you're aiming to sample is not correct in a sense of giving every fragment or particle in that lot a chance of getting in that sample. And the classic there is convenience sampling. We've already spoken about the blast hole, and you can't get to the bottom, and sampling the tops of trucks and stockpiles. Let me think. What else is there?
So what about the human errors? Are they important? Can they be significant?
I think that they can be very significant. mixed up samples is probably the biggest issue I've seen in the industry. Going back to my early days in gold, where we used to write the numbers on the bags and put them by the blast hole, and you'd pay a field assistant to do that, and at some point they'd lose count.
Yep.
And you'd end up with 2 number 9s or whatever. And then it would throw everything out across the whole bench to be mined from that point. So that was a really big mistake.
Yeah.
And you couldn't always solve it either, because the guy might have gone offside, or
Yeah.
or the lab will get 2 number 9s and not know what to do with them.
Yeah.
The other classic example, and we see it a lot now, is we use certified reference materials, and they go into the lab to check accuracy, and they come back with this grade that's way different from what it's supposed to be. And it's just been a human error of putting it in there.
Right.
And then negates your whole process of trying to monitor accuracy.
So what we say, and indeed we say this in our training, and I know you would say it too, in theory, we call these incorrect errors because in theory they can be eliminated. Do you think they can ever be totally eliminated, our incorrect errors?
No, because it's a human process, and a lot of the engineering design is by its nature incorrect. So, if you look at RAB sampling, for example, it's going to rattle out the hole, and you're going to get different, sizes of samples as the meters go down. You can have good procedures. You could do monitoring, but there's always going to be errors that creep in, and I know they creep in because working in active mines, we have reconciliation periods which just don't seem to make sense. You look at the data, you look at the estimation, things have worked fine for 5 years, and then suddenly it all goes strange for some unknown reason, and you think, was there some error? Was that hole actually not in that location that I used to do that ore body, or was those samples, did they go to the wrong lab? And unfortunately, you just never know, but I think it's always there.
So with respect to this mixture of our so-called correct errors and incorrect errors, I guess what you're saying is we need to be aware of what can cause the correct errors, the fundamental sampling error and the grouping and segregation error. And with the incorrect errors, we essentially need to have our wits around us. Would that be a fair thing to say?
Yeah, very, very much so. I think you've got to have, clear procedures, good monitoring of those procedures. If you don't police, you won't get compliance. And you've also got to have that regime of checking, things like, I'm a big fan of duplicate sampling to see if there's problems, and twin hole drilling to see if there's problems, less so on, CRMs, etc. So,
speaking about duplicates, one thing that I've learned from you is this idea that when we're doing duplicate sampling, we need to look at the location of those duplicates in the ore body. Can you just explore that one a little bit for us?
Yeah, sure.
As opposed to just the numbers themselves.
Yeah, so something that struck me a few years ago now is that we do all this duplicate sampling, but do we actually look where it's at? So I went to a lot of trouble to investigate on one ore body that when we show a plot of replicate sampling, we actually show where those replicate samples are. So if, have we sampled replicates across all the ore body? Have we sampled it in a manner that's just not systematically in layers, for example? Because a lot of people just go from the top of the hole down, and that, has the probability of, if you've got layered geology, your replicate's actually missing important parts of the geology. So I think spatial understanding of where it is, and it all comes down to comfort, because ultimately if you're preparing a resource estimate and it involves borrowing a large sum of money or investing a large amount of your company's money, someone like yourself, Ian, will come in and say, well, give me comfort that your sampling is of good quality and representative of this ore body. So I'm a big fan of making simple graphics that demonstrate not only have I got this repeat precision, but I've done it in these areas in all parts of the ore body, and look, there's a gap here because it's old drilling and I didn't have any information, and it just makes your job easier. As Harry Parker used to say, the auditor wants to go through the job in blue suede shoes, not field boots and a machete.
Yeah, sure.
That's your job as a geologist.
Yeah. So one final question. You've mentioned the word duplicate. You've mentioned the word replicate.
Yeah.
How would you differentiate those two terms?
Well, I'd say there's only one term, and that's replicate.
So, oh, really? Okay. So what's
Okay.
the difference between a replicate and a duplicate?
Well, a replicate, in science we do replication, right? So, and this is across all sciences. So the idea is that you can reproduce a result under the same conditions as the first result. And it's not necessarily at the same time, and it's not necessarily at the same place, but it's a replication of that process. So we have all these terms like, repeat, duplicate, there's another one, I can't remember, but there's a lot of these terms. But in reality, they're all replicates. And I think the sooner people use one term and then explain exactly what they're doing, rather than trying to define all these separate terms, it'll be clearer. So, a pulp replication is taking another sample from the pulp at the laboratory at that time. And you can also have a pulp replication at a different laboratory.
Right.
And this is this check sample thing.
Yeah,
So
yeah.
To me, they're all replicates because you're comparing one to the other.
Okay, cool. Thank you, Mark.
Okay.
So that was our second of three, and we, as you heard, we've explored some of the issues of sampling. Thank you very much.
Yeah, thank you.
If you enjoyed that, please subscribe, and you'll find us where all good podcasts are to be found.